We're going to be talking about the commands used to configure the switch and how we configure the switch, switchport security, verifying connectivity. People are complaining they can't get onto the network, as well as troubleshooting poor connectivity. Now, I've brought up a diagram of a network I've loaded into my simulator. I have a center switch, which is 2950 switch. The 2950 switch is the switch that the Cisco CCNA test revolves around. I've got 4 PCs connected to it. Palestra 1 is connected to port 1, Palestra 2, port 2, Palestra 3, port 3, and Palestra 4 on port 4. I'm using the 192.168.1.0 network address with a /24 subnet mask. /24 is bitwise notation. The subnet mask is 255.255.255.0. And I've given each PC an IP address of .10.20.30.40. The switch IP is going to be .1, but I have not configured the switch IP. So let's take a look at what we have to go in and do to the switch that will allow these 4 machines to have connectivity with one another. Now, I've gone in and configured the design in the simulator I'm using. I've set up a center switch, switch 1, and then the 4 machines and connected them to the appropriate ports. I have not done any configuration to the switch whatsoever. It does have power to it and does have the cabling connected up. The 4 machines have been configured with their IP addresses, but nothing has been done to the center switch. I connect to the switch in the simulator, and I go from user mode to privilege mode by typing in the enable command. And real quick, I'm going to go in and take a look at the initial configuration of the switch. Show running config allows me to view how the switch is initially configured. Name is switch, IP subnet 0 allows it to use the 0 subnet. Spanning tree we will be talking about later. And all 12 interfaces on the switch have no configuration underneath them. We see a VTP domain, which again we will talk about later. Interface VLAN 1, which is where we put our IP address. And I will be going over that in a moment. And then we see the rest of the configuration for the switch here is totally blank. Now, all I need to do to allow these machines to connect to each other is nothing. If I just leave the switch alone, plug power into it, hook the computers up to it, the switch will do its switching function. It'll allow the machines to communicate. If I go into Palestra Computer 1 and I ping some of the other machines, IP config allows me to view my IP address. It's 192.168.1.10. I can go in and ping 192.168.1.20, and I'll get a response back. I can go in and ping .1.30, get a response back. 1.40, get a response back. So I don't have to do anything to the switch to get it to function. It's not like a router. All the switch needs is power plugged into the back. A lot of switches do not even have a power switch. They just simply plug the cable in, or the power cord in the back, and then go in and hook the machines up and it'll function. Now, there is some initial configuration or basic configuration we can do to test connectivity. And that first thing would be going in and setting an IP address and maybe configuring a host name. Let's take a look at some of those commands. So I'm at the switch here, and again I did a show running config to view the current configuration. The first thing I might want to do is go in and set a name for the switch. Right now it's at a default name of switch. I want to go in and set the name to something completely different, switch 1. Like I've said before, everything you view in the running configuration is a valid command. So all I have to do to go in and change the host name of the switch is go into global mode and type host name and then the new host name. I get to global mode by typing configure terminal. I could also just type the shortcut CONF space T. And I type hostname switch 1. And I've just changed the name of the switch from switch to switch 1. After we change the name, we might want to do something else like set an IP address. If I look right now and I type show run for show running configuration, interface VLAN 1 is where we would set an IP address. Why would I want to set an IP address? Mainly just so I can test connectivity and I can manage the switch remotely. I might be setting up simple network management protocol traps on the switch, which allow me to monitor the switch. I might want to be able to test connectivity by making sure I can ping the switch. For those things to function, I need an IP address, and this is where I put an IP. But what the heck is interface VLAN 1? To know that, we need to know what a VLAN is. So let's go in and take a brief overview of what a VLAN is before we come back and set this IP address. Now, I've brought up the slide of the switch so we can talk about what a VLAN is. A VLAN stands for virtual LAN, and all it is a broadcast domain. By default, there is VLAN 1 on a Cisco switch, and all ports are in VLAN 1, meaning all ports on the front of the switch, port 1, port 2, port 3, and port 4, I can count really well, all 4 of those ports are in VLAN 1 by default, meaning they are all in the same broadcast domain. So, what effect does that have on the computers? If Palaestra 1 sends a broadcast message, Palaestra 2, 3, and 4 will all receive that broadcast. What we can do with these switches is we can chop them up and basically create more than one broadcast domain. I have the ability to go into the switch and create VLAN 2. Just because I've created VLAN 2, an additional broadcast domain, doesn't mean anything is in it. If I wanted to, I could put ports 1 and 2 in VLAN 2, and ports 3 and 4 would be the only things in VLAN 1. What effect would that have on the computers? The effect would be now that ports 1 and 2 are in VLAN 2. If Palaestra 1 sends a broadcast message out, only Palaestra 2 will receive that broadcast message. 3 and 4 will not. The reason they won't is because the switch will not allow it. It's almost like the switch has been cut in half. 1 and 2 can communicate, 3 and 4 can communicate, but 1 cannot communicate with 3 or 4 because the switch will not let it. That's what a VLAN does, and that allows us to create or finely tune our broadcast domains to make for a more efficient communication method and to cut down on traffic in our network. The only thing that can go in between these domains would be a router. We would need a router if we wanted to be able to have Palaestra 1 talk to Palaestra 3. We'll be getting into inter-VLAN routing in later video. But for now, just remember that all ports on the switch, not just 3 and 4, 1 through 12 on the switch 1 that we're working on are in VLAN 1. So the IP address of the switch is going to be in VLAN 1. That's where that interface VLAN 1 comes from. Let's go in and configure that IP now. So I've gone back to switch 1, and I want to configure that IP address on interface VLAN 1 here. Right now it says no IP address, so we can't test connectivity to the switch by pinging it. We can't set up management of the switch. So we want to go in and set an IP address right now. I can't telnet into it. So all I have to do is go into global mode. CONF space T takes me to global mode. And the command, again, everything I see in the running config is a valid command. So the command I have to do is type in interface VLAN 1. I'm going to type that in first. And then I'm going to set the IP address. Interface VLAN 1. Enter. Now I'm at the interface mode for the switch. And I forgot. I forgot the command to set the IP address. So what can I do? I can just look in the running configuration. It says no IP address. So what that tells me is if I want to set an IP address, I just put IP address. Just forget about the no. So IP address. If I don't remember what comes next, I can put a space and a question mark, and it says, hey, I want an IP address, and this is the format I want it in, A, B, C, D, meaning dotted decimal. So 192.168.1.1 is the IP address we're setting. If I don't know what comes next, put a space question mark. It says, hey, I want the subnet mask, and I want it in dotted decimal format. 255.255.255.0. I hit enter, Control Z, show run, and I look in here and I see interface VLAN 1, no IP IP address, not no IP address, IP address 192.168.1.1, 255.255.255.0. So I've set the IP, the interface is on. Now I should be able to test connectivity between the machines. So I can go in and ping those machines from the switch now. That can be helpful when you're trying to figure out where the connectivity in a network is stopping. Let's go in and test that. One thing before we go test that connectivity real quick. If I need to be able to get outside of my broadcast domain, meaning I need to go through a router, and I need that connectivity from the switch to be able to go through a router, I must go in and set a default gateway. The command to set the gateway is a global mode command. It's not under interface VLAN 1, and it's IP default gateway, and I would put the IP address of the Ethernet interface of the router that's closest to this switch. 192.168.1.254. If there was a router out there with that IP, that would be the gateway. Now, with the proper gateway set, I could go in and telnet to the switch from externally to this broadcast domain. Now let's go in and take a look at that connectivity. Now all I have to do to test connectivity is ping from the switch to any of the machines or vice versa. Now, by receiving a successful ping or a response to my pings, it tells me that layers 1, layer 2, and layer 3 of the OSI model are functioning perfectly well. Layer 1 being the cabling, power turned on, all the connections made appropriately. Layer 2 being the Ethernet encapsulation. And layer 3 being the IP addressing. Once I've got the host name, IP address set up right, I might want to go in and lock my switch down a little bit, so if somebody does try to connect to my device, they're not going to have access without having to enter a password. So the first thing I would do is I would type in enable secret, and I wouldn't necessarily use Cisco. I'd use something a little bit harder for people to guess at, but I'd type the enable secret password, and that's the password that prevents anybody from getting from user mode to privilege mode. If I exit out and I'm in user mode right now, I type the disable command to go from privilege mode to user mode. I type enable. I get hit with a password prompt now. I didn't get that before. And the reason I get hit with that password prompt is, again, the enable secret Cisco command. And this is the same that you would do on the router. So the password I have to type in is Cisco. If I type it right, it'll take me into privilege mode. So after typing it correctly the second time around, I get into privilege mode. I know I'm in privilege mode because of that pound sign. A couple other passwords I want to put in. If I go to global mode, by typing in configured terminal, I go into line console 0, and what this does is it locks down that console port on the back of my switch that people use to connect to. I type password Cisco, enter, and type login, and login turns on the password prompt. That way, if somebody tries to get to my system, they plug into the line console in the back, even though they have physical access, they're going to have to enter a password. Then I go to the line VTY space 0 space 15, and I type in password Cisco, and again turn on the prompt. So if anybody tries to telnet in, what line VTY 0 space 15 is is I can have up to 16 telnet sessions at one time. 0 being the first, 15 being the last, 0 through 15, that's 16 possible telnet sessions going on at one time. What this does is I've put a password, the same password, on every one of those telnet sessions. If I wanted to, I could just go line VTY space 0 space 4 and configure 4 telnet sessions with a particular password. I can also assign different executive privileges based on the password that admins are entering when they access the switch. So it allows me some flexibility there. Control Z, show run, and I can go in and check out all my passwords. There's my enable secret, and down at the bottom I've got password Cisco and password Cisco for line console, as well as the telnet line V2Y space 0 space 15. One thing, service password encryption, right now it says no service password encryption. If I type in service password encryption in global mode, what it does is it'll go in and encrypt these passwords. So if anyone were to come in and check out the router, let's say I walked away from the router, I didn't log out, I do a show run, somebody could come in behind me and they could go in and check out these passwords, and that way later on they would have these passwords available to them. By keeping them encrypted, it makes it a little more secure. Now, one thing about locking the switch down, if somebody has physical access to this thing, not much you can do. Even though I have these passwords set up in my running configuration, the switch is using them at the time. I even save the running configuration by going copy run, which is running config, to the startup config. So I'm saving it, so if the switch were to be rebooted, the passwords would be there. It's very easy to get around passwords if you have physical access. So keep your server room locked. Let's take a look at some additional security we can add to the switch by preventing unauthorized users from getting into or plugging into our switch. I've brought up a slide here showing the center switch, switch 1, and the forwarding table, as well as 2-character MAC addresses for each one of the Palestra PCs. So MAC address for Palestra 1 is 7C, and the forwarding table basically is completed at this point. So port 1, 7C, port 2, B9, port 3, D7, port 4, 4E. So the switch knows what interfaces it needs to go out of to get to what particular device. What port security can do is, if an unauthorized machine were to plug into the switch would detect the MAC address and take an appropriate action. Let's take a look at what I mean. This switch, switch 1, and our SIM has a total of 12 ports on it, 1 through 12. Even though we're only using ports 1, ports 2, ports 3, and ports 4. So if we were very worried about security, what we would do is ports 4 through 12, they would be shut down. So that way, if they had a cable running to a wall jack somewhere, or somebody was able to plug directly into one of those ports, that system would not function on the network. Switchport security takes this a bit further. Let's take a look at the example of Palestra 4 here. MAC address is 4E, and in the forwarding table, the switch knows that 4E is destined for port 4. So what we could do with switchport security is say, hey, 4E is the only MAC address we want to communicate on port 4 here. So 4E is it. If any other MAC address tries to communicate on port 4, I want you to shut down. So what could happen is somebody could take their laptop, unplug Palestra 4 here, plug in their laptop into the network. This is a picture of a laptop, by the way. They're plugging their laptop into the network, and the laptop's MAC address might be 6D. So the switch, when this laptop tries to communicate, the switch recognizes this MAC address of 6D as trying to communicate on port 4, and it goes, hey, only 4E can communicate on port 4. Since this is not a valid MAC address, I'm going to shut the port down. So if this laptop here were to try to plug into any port on the network, the ports 4 through 12 would either be shut down, or they would already have MAC addresses associated with the port and cannot communicate on the network. That's a very helpful addition to your physical security. A lot of companies, if you want to go swap out a MAC address on a machine, let's say we wanted to change the network interface card, not MAC address, we wanted to change the network interface card on Palestra 4, maybe it went out. What we'd have to do is we'd have to find the MAC address of the new card. It might be 9A. We'd have to find out the MAC address for the new card and go and reprogram the switch, so the switch, we're expecting 9A to communicate on port 4 instead of 4E. So we'd have to actually go in and reprogram the switch. And then again, if an unauthorized MAC address tries to communicate on the network, the port will go ahead and shut down. And if it's an unused port, it'll already be shut down. So very helpful addition to physical security. Let's figure out how we can go in and configure this switch port security. Let's bring up the simulator. Now I've brought up the simulator, and the first thing I want to do is I want to go in and shut down all unused ports. So I've entered into global mode, and what's cool is I know interfaces 5 through 12 are not being used. So I'd want to go in and shut those down in case somebody were to plug into them. They'd be a dead interface and they wouldn't be able to communicate on the network. So what I can do is I can use the interface range command. So I go interface range FA for fast Ethernet 0/5 space dash 12. And what I've done is you can see it says configure interface range. And I've got the range of interfaces 5 through 12 here. What I would do is I'd just type shutdown, and it would shut down all interfaces of 5 through 12. So each one of those interfaces is shut down. Now, even though it doesn't show up on the simulator, if I do a show run, what would happen is I would go in and I would see the shutdown command underneath each one of these interfaces on a regular switch. Again, I'm using simulator. Sometimes it's not going to be quite that hot. So in this situation, I would see the word shutdown underneath these interfaces here. However, again, I'm on a simulator, so I don't get 100% of the functionality. I get 99% of it. And it works well for this purpose. A couple little differences you'll notice. Now, I've shut down all interfaces that I'm not using. So what I want to do now is I want to go in and configure the interfaces that I am using to only allow the MAC address that the switch has detected to communicate on that interface. So I'm going to first start by going to interface FA0/1, and I'm going to turn on port security. So I'm at my interface of FA0/1, which is interface fast Ethernet 1. Palestra 1 is plugged into that interface. The first thing I want to do is I want to use my Switchport command to go in and tell the switch that the MAC address that is currently at the interface is the one I want to make secure. So I go Switchport, port security, and then I use the command MAC address sticky, and what it'll do is it'll detect the current MAC address on the interface and make it permanent and use that one on the interface. So whatever MAC address is there, the sticky means to detect it and make that a permanent entry in the MAC address table instead of a dynamic one. By default, all entries in the MAC address table are dynamic, meaning they time out if they don't hear from that device for a while. So by making it sticky, it puts it as a permanent entry in the MAC address table, and then I can turn on my security. So I go port secure MAC address sticky. By default, only one MAC address can communicate on the port when I'm turning port security on. So I've turned on port security MAC address sticky. And after I hit enter on the Switchport port security MAC address sticky command, I have to go in and turn it on. So all I have to do to turn it on is use the Switchport port dash security, and that turns it on. By default, if a different MAC address than the one that was detected with a sticky command is trying to communicate on port FA0/1, that interface will shut down. If I want to, I can have multiple MAC addresses communicate on a port. I can use the maximum command, and I can have up to 132 MAC addresses available on a port. You might ask yourself, why the heck would 132 MAC addresses need to be communicating on a port when only one computer plugs into the port? It might be an uplink port. It might be a port that plugs into another switch, and there might be 50 nodes on the other side of that port. Or you might be plugging into a hub that's got 50 nodes on it that you don't want anybody else to be able to plug into. So there are situations where more than one MAC address will be communicating on a port. Well, let's take a look at some of our show commands to go in and view all of this configuration we've done. Brought up a slide with the important commands here. Show running config, the most important command. Put a star next to it, multiple stars next to it, whatever you need to do to remember this command. Show running config. Everything that you actually configure will show up in the running configuration. Remember, running configuration is stored in RAM, and that's how the device is currently configured to operate. Startup configuration shows you what's stored in NVRAM, and that's where you would save your changes if you liked what you had. So if you like what's running in RAM, you would go ahead and save it to NVRAM, so if the device were to be restarted, this is the configuration that the device would use when it started back up. Copy, run, start, or copy running config, startup config is the command you would use to save your running configuration into RAM. Show MAC address table shows you your MAC address table entries. You can either do it with just show MAC address table, or you can put dynamic or static on the end of it. Just slap that on the end and take a guess. If you put dynamic at the end, you'd see the dynamic entries, the entries that would time out. If you put static at the end, you'd see the static entries, the ones that are permanent. And another one, if we want to actually check out our security for a particular interface, we go show port security interface, and then whatever interface we wanted to look at. And that would show us the status of our security, whether it was on, off, things like that. So these are some very important commands to be able to go in and view how the device is configured and how it's operating. Another command that I forgot to put up here is just show interface. Show interface, show interfacer, just show interface. What happens when you type that in is you'll be able to see whether the interface is up or down. Let's actually go take a look at that one real quick. So if I type in show interface, it shows me the status of the interface. Not necessarily everything how it's configured, but the status of it. Let's take a look here. Fast Ethernet 01 is administratively down. Line protocol is down. What that's telling me is right now that the interface has been shut down, and to turn it on, I would have to actually go to the interface and type no shutdown, interface FA0/1. If it says administratively down, I go to the interface and I type no shutdown. And that would go ahead and turn the interface back on. So it would say up. So show interface is a very helpful command when testing connectivity. Let's take a look at some troubleshooting and how we can use these commands. Now, to talk about some basic troubleshooting here, I brought up the net map that we're looking at. So switch 1 is the center device, and we've got our 4 computers plugged into ports 1, 2, 3, and 4 on the switch. So how I would test basic connectivity, the first thing I would do is ping. I go to computer Palestra 1, and I try pinging the other machines. I'll try pinging .20. So that works. Pinging .30. That works. Pinging .40. That works. So I go in and check out and make sure that everybody can ping each other. If for some reason one of these switches or one of these devices cannot ping, let's say Palestra 1 cannot ping Palestra 4, I would try to look at, okay, what can Palestra 1 ping? Can Palestra 1 ping the switch? So I would just try pinging the IP address of the switch. That's one of the things that's helpful in having an IP on the switch, even though it's not necessary. Since I got a reply back, it says reply from 192.168.1.1, I got a reply on that. That tells me that the cabling between Palestra 1 and the switch is good, that power is on, the cables are plugged in right, all that, Ethernet is working appropriately, and IPs are good. So what I would do at that point is I'd go in and check out Palestra 4 and see if that could ping the switch. So I'd use ping as a way to kind of narrow down where I think the problem might be. On the switch, a couple other things I could check out is I would do show interface. If, let's say, the machine was unable to ping the switch, it's plugged into fast Ethernet 01, I'd make sure it said is up, line protocol is up. This right here verifies that layer 1 and layer 2 of the OSI model are functioning appropriately. This first part refers to layer 1, second part refers to layer 2. Since it says is up and up, then I know layer 1 and layer 2 are good. If I had MAC address table security, I might check out that. Show MAC or show MAC address table. Take a look at the MAC address table and make sure that it's populating MAC addresses, things like that. So very important to check layer 1, layer 2, layer 3 when we're testing this connectivity out. Verify that the IP is right as well. All the time I see people overlook a mistyped IP. So it's very important to look at layer 1, layer 2, and layer 3 of that OSI model when we're testing for connectivity. We have talked about commands and configuration for the switch, port security, verifying connectivity, as well as troubleshooting.